Hi friend, how are you? I hope you and your family are doing well. Dear friends, today we have come here to understand what is quantum mechanics. Understanding the definition and the fundamental of quantum mechanics is very important to study quantum mechanics in depth. So today we'll study, discuss about the definition, history of birth of quantum mechanics, and now let's try to understand what quantum mechanics is. Dear friends, quantum mechanics is the study of motion of microscopic particles like molecules, atoms, subatomic particles, elementary particles, etc. The motion of microscopic world is quite different from the motion of microscopic world. The motion of microscopic world is quite different from the motion of macroscopic world. Microscopic world means the world which dimension is of atom, molecules and elementary particles is known as microscopic world, and macroscopic world means the world which is by seeing us, which you can understand by touching, and many more senses. We'll discuss the origin of quantum physics and the history of physics. Quantum physics started from disagreement between observed and theoretical curves of spectra of black body radiation. As we have already discussed, dear friends, quantum mechanics is the study of microscopic particles like molecules, atoms, subatomic particles, elementary particles, etc. Now let us discuss the origin of quantum physics. The history of quantum physics started from the disagreement between observed and theoretical curves of the spectra of black body radiation. It was a big problem for physicists at the time. It was German physicist Max Planck who modified the Wien's law and proposed an idea of energy packets. This new idea was able to explain the spectrum of black body radiation. Using this new idea, Einstein explained the photoelectric effect, and Niels Bohr proposed modified version of Rutherford's atomic model, which later known as Bohr's atomic model. But what was the idea? What was the new idea which Max Planck proposed? According to Max Planck, the exchange of energy between radiation and matter takes place in the form of energy packets. The energy packets were called as quantum. The energy of one quantum is given by E is equal to h nu, where h is a constant known as Planck's constant and nu is the frequency of radiation. This idea of Planck was very revolutionary idea and gave birth to quantum physics. Later, French physicist de Broglie combined two equations, E is equal to h nu and E is equal to mc square, and concluded that light has dual nature, wave as well as particle. Then he generalized this concept to every moving material particles. According to him, every moving material particles possesses wave nature. The wave associated with material particle was called matter wave. The wavelength of a matter wave is given by the formula lambda is equal to h by mv. H is Max Planck's constant or Planck's constant simply. M is the mass of the particle and v is the velocity of the particle, moving particle, is equal to h by p, where p is momentum, is equal to mass into velocity of the particle. This concept of matter wave was other pillar of quantum physics. Two American physicists, Davison and Germer, demonstrated an experiment to find out experimental evidence for the existence of matter waves. They discovered the diffraction of electrons, and since diffraction is the property of wave, so it was concluded that electron has also wave particle duality. Now, this was the first experimental evidence of the existence of matter waves. Later, German physicist Hedenburg proposed another fundamental principle of quantum physics, namely Hedenburg uncertainty principle. According to this principle, it is impossible to determine simultaneously both the position and momentum. Momentum is associated with velocity of a particle with accuracy. In other generalized form, this principle is stated as the values of two canonically conjugate variables cannot be simultaneously measured with accuracy, that is zero error, for a microscopic particle. The product of uncertainties in the simultaneous measurement of conjugate variables always has a value above a certain minimum is equal to h by 2 pi. After that, Austrian theoretical physicist Erwin Schrodinger discovered the wave equation for matters, and Max Born interpreted the de Broglie-Schrodinger waves as wave of probability. Thus, quantum physics was developed into another category of mechanics known as quantum mechanics to study the motion of microscopic particles. To understand quantum mechanics, two things are very important for physicists. First, higher mental imagination, and second is the knowledge of higher mathematics. Dear friends, quantum mechanics uses very high level of mathematics. So when we try to understand the theory of quantum mechanics, the laws, fundamental laws of quantum mechanics, then we come across a very high level of mathematics. So we should have to also focus on mathematics, higher mathematics, so that we can understand quantum mechanics. Dear friends, this is my first lecture on quantum mechanics, and I will make a series on the lecture of quantum mechanics known as a journey to the introduction of quantum mechanics. So please friends, like this video, subscribe and share, so that you will get notification from the channel for the further